right, we try as much as possible to create that stability, okay, by enhancing that or stabilizing the surface of that contact area. All right. Now, you find out that when this load is being transferred, okay, especially for example your pad foundation, you see that it is the pad footing that actually, or the pad base that actually spread this load. All right, so it's important that we create a leveled surface, okay, contact area, for effective spread of this load. Now, once there is imbalance, okay, once there is a kind of an imbalance, equilibrium is not maintained, you see that will have implication on that pad footing. All right, because in terms of the punching stresses will be also encouraged with such an uneven contact area. All right, because you see that those pads are expected to be seated on a leveled trench base. Okay, now you see that most times when we do our excavation, like the buildings we have around, they are predominantly the type of foundations that are adopted are mainly your pad foundation, your strip foundation, and in some cases raft foundation. Now you see that when you do excavation, most times there are specified depth for excavation. All right, there are specified depth, but you see that in the course of excavation, some of those that do the excavation usually go below the stipulated depth. All right, they exceed that depth that is that is actually meant for that particular type of foundation. Now it's important that when that happens, there are certain things that you need to do in order to improve that depth. Okay, you see that, for example, in a clay soil, once you excavate a particular soil, for example, a clay soil, it is practically difficult for that soil to be recompacted, to attain that level of compaction. In the case of clay soil, okay, it is very, very difficult. So that is why it's important that when you do your excavation and you exceed that depth and you want to still maintain that particular depth, it is not advisable to use the excavated soil and try to reintroduce it back and compact. When you do that, like your clay soil, during the dry season, the clay soil tends to be hard and it forms lumps. Now, when you now drop these lumps, this excavated soil, and try to apply some form of compaction, at that point in time, it might look compacted. But once the seasonal changes takes place, that is the wet season comes to play, you see that the swelling tendency will now make the volume of that soil to be reduced. And once it is reduced, it means that every other load, that the gravity load now will tend to respond to that decrease in volume. And that brings about settlement in our structure, and in some cases differential settlement. So most times you see that when we have our strip foundation, our strip foundations are mainly resting on the thickness of our concrete. Okay, in most cases plain concrete, okay, PCC. All right, they are resting on PCC. So you see that any form of tension will bring about crack. Okay, and that crack will lead to a kind of separation. There will be that connectivity will no longer be there. All right, so you see that will bring about distortion in the substructural arrangement. All right, so it's important that when we do our excavation, we shouldn't neglect that aspect. If the depth is expected to be maybe 1.1 meter, that is 1,100 millimeter depth, it's important that you create something, a template, okay, which the people doing the excavation can take reference. Okay, they can use it to be referencing, not to exceed or go below maybe a depth of 1.3, in some cases 1.2. Okay, you see that it has gone below the expected depth. All right, and if peradventure it happens, there are certain measures that you need to take, and